Hello friends, welcome to the next class of computational physics. Till now we learned the basic requisites required for a computation, and we know that if you want to define your problem very clearly, then you should understand the problem very clearly first. And to define the problem in a logical manner, there are two tools which we can use. The first is known as algorithm and second is known as flowchart. In today's lecture, we will see the details of flowchart. So flowchart is basically a way of representation of algorithm in a pictorial manner. So you can represent whatever text instructions you are giving through algorithm, that into the pictorial form. So here it becomes very easy to understand the logic and the flow of data from start to end of the problem solving process. So in short, the definition is the pictorial representation of algorithm using geometrical shapes with predefined meaning is known as flowchart. Now what do my predefined meaning? Predefined shapes means those shapes have their some specific meaning. Not all geometrical shapes are allowed in a flowchart, but some are standardized by American National Standard Institute, and these shapes, that is known as ANSI. So these shapes we can use to construct the flowchart. So let us see what are they. The symbol, name and meaning. The first is known as terminal. This terminal or oval or terminator is basically used to represent start or end of the process or flowchart. The second is parallelogram, or it is input or output. It is used to take input or to print output or to give output after the process through flowchart. The next is known as a rectangle, or it is also known as process. So whatever process you are doing, that process you can represent with the help of rectangle. Then arrows are basically known as flow lines. They are used to show direction of flow of operation by connecting the different symbols of flowchart. The next is decision. So if you want to check any condition, that you can put in a decision box. So it is used to make a decision. The next is connector. So alphabet in a circle connected with arrow, that you can use to connect different parts of flowchart. So if your flowchart become too lengthy from one page to two page, then this flowchart branches you can connect with the help of connector. Then this is known as predefined process. It is used to represent function. Then module call, it is used for calling a function. And then dotted block, this is used to represent body of a loop. So if certain number of statements repeated again and again, then that you can represent with the help of this block. There are some advantages and limitations of flowchart. The advantages are better communication, simplify the logic, effective analysis, effective coding, systematic debugging, and proper documentation, and a general purpose. Also the limitations are time consuming, need to construct with proper symbol. For complex logic, the flowchart become too lengthy and it also become very complex. Once you have a flowchart, it becomes very difficult to alter the flowchart if any mistake encountered during construction. And for big task, the flowchart become too lengthy, so there will be so many branches, so it become difficult to understand the logic of a problem. Now let us see some examples. So the first example is to read a number and print it out. First we will see algorithm for this. So the first step is start, as we know. The second step is read the number. So enter any number n. Then third step is print whatever number you have taken as the input. And fourth step is stop. So this is very simple algorithm to take a number and print it. Now let us see how the flowchart will be for this. So first step is start, as it is in terminal. Then second is input, hence it is in parallelogram. The third step is output, hence it is also in parallelogram. And the last step is stop. So start, read number, print number, and stop. So with the help of these four steps, you can easily convert your algorithm into flowchart. Similarly, consider next, that is addition of two numbers. So the algorithm for this is start, read any two numbers or enter any two numbers A and B. Do addition of these two numbers. So C equal to A plus B. Then step 4 is display value of C, and then end. Now let us construct algorithm flowchart for this. So first is start in terminal, second is read any two numbers, so that is in parallelogram as it is input. Then third is process, that is C equal to A plus B. Then next is print C, this is output, hence in parallelogram, and then stop. So start, read the number, C equal to A plus B, print C, and stop. So here read number means A and B. So these two numbers you have to take as a input. Then next is to check whether given number is positive or negative. So start, read number. Now check, this is a decision box. So you can see here, if n is greater than or equal to 0. If yes, then print n is positive, and if no, then print n is negative. So first how this flowchart will execute. So start, then read any number n. After this, go and check whether number is greater than or equal to 0. If it is greater than or equal to 0, then the flow will transfer to this particular block, that is print the number is positive, and then stop. If number is not greater than or equal to 0, that simply means the number is negative. So go to this particular box, print number is negative, and after that stop. So here you can use a decision box to make a decision for that particular condition. The next is flowchart to find a pressure at different volume using equation PV is equal to RT. So start, read initial volume, final volume, R, dV and T. So let V equal to Vi, then calculate P from ideal gas equation, that is PV is equal to RT. So P equal to RT divided by V. Now you have calculated pressure value, then increase the volume by V plus dV and print V and P. Now what is mistake in this particular flowchart? The mistake is this block should be about this, because whatever pressure you are calculating, that pressure is for this volume, not for this. Okay, then check whether V is less than or equal to Vf. If it is so, then go and again calculate the pressure, and once it become greater than final volume, then stop. So purposefully I have added this particular mistake in this particular flowchart. So while printing the values, you must understand at what stage you want to print the value of that particular problem. Then this is a flowchart for Fibonacci series. We know the Fibonacci series is a series which generates different number of terms. The next term is addition of first two succeeding term. So the third term is addition of first and second term, fourth term is addition of second and third term, and so on. So here start, read the number of terms in a series, let's say n. Then first term, as we know, that is f1 is equal to 0, then f2 is equal to 1, and count is equal to 2. Now print the values, print f1 and f2. Then calculate the third term, f1 plus f2. So do addition of this and assign that value to f3. Now print f3. Now see, your count become, this is 2, this is 1, so increase count by 1, so count is equal to count plus 1. Now you can see here, this is output, this is also output, and this is process, this is process, this is input. So for input we are using parallelogram, for process we are using rectangle, and for output we are using again parallelogram. So after increment in count, check whether your count is less than or equal to n, because you want to generate the number of terms. 3 terms are already generated. So if n is less than or equal to n, then do this, alter the value. Now assign value of f2 to f1, assign value of f3 to f2, and then go and again calculate the new term f3. Repeat this process till your count is less than n. Once it become greater than n, then stop the execution of your flowchart. So in this way you can easily generate the flowchart. Now you can see here, in last lecture we have seen the algorithm for this Fibonacci series. Now as compared to algorithm, it becomes very easy to understand the logic through the flowchart. So this is all about flowchart. Thank you.